I am Barry Devkinath Maharaj, and you can visit learn.mo.gov.tt where you can find resources for ECCE, primary and secondary. This is where we help students connect and continue learning. So we are looking at primary science today, and we are focusing on standard 2. The strand would be form and function, and the topic for this session would be movement of water through soils. So before we go into the depths of it, we are all familiar with soils. We notice when we go to the beach, when we go to the garden, when we are doing construction. And the key thing about it is noticing that there are many differences in all of these types. So to get familiar with them, we would look at the soil particles. So we have sand, silt, and clay. Each of these are different. And when we say they are different, this means that their properties, all the characteristics, all the things that make them unique are different from each other. So we need to know about everything about soils and what they do. So one very important characteristic that we need to take into consideration is that soil acts as a type of sponge, and it absorbs water. And this could be seen in the different soil types. So very important with soils and the soil particles, which eventually make up the soil type itself, is the shape and size. And how this gives the properties is that in between each particle of each soil type, we have tiny spaces in between each individual particle. And it is within these spaces the water can move through the soil. So the soil particles, again, we have sand, silt, and clay. So we need to go in order, and as a follow-up from classification and grouping, clay has the smallest particles, while sand has the largest particles. And this is primarily because it's clay, and because it has that small size, this is why we give that smooth feeling. As compared to when we go to the beach and we are building a sandcastle and we play in that dry sand, the particles are way larger and they are rough, they are coarse. So immediately we could tell a difference from when we are using a Play-Doh or we are at the beach. And these are properties of soil particles. And we are actually doing science while enjoying ourselves in our day-to-day lives using our powers of observations. And this is what makes a good scientist. So we look at the comparison of sizes now. So here we could see a diagram comparing the different sizes of the particles. So the largest circle in yellow is the coarse sand. So the grittier it feels, like the beach sand, this is how it would compare. And remember, these are not real sizes. These are by comparison. Like if we take each of these soil particles, put it under a microscope and zoom it up and make it look really large and compare them, this is what we would see. So back again, the coarse sand is really large. It's and when we look at it, it's bigger than the rest. And then we have a smaller circle in green, which would be the medium sand. Then we have the blue circle, which represents fine sand. And we have a red circle, which is silt. I'm not sure if you might be able to see it, but next to the word clay, there is a black dot. That black dot represents the size of a clay particle. So when we look at the size of that clay particle, which is a dot compared to this big circle here, we could immediately see there's a difference in size. And that would give all the properties when we put it together in millions of particles together, we would actually get the properties of that soil being unique. So again, just to review that these are comparison of the sizes of the particles themselves. And just to remind you all, we have coarse sand, medium sand, and fine sand. Those are three smaller categories of the types of sand particles you may find in a soil type. Right, so those are the particles. So when these come together, we would actually have soil type, because we may not find only one, or we may do. It depends on where we locate it and the source where we find it. So we have sandy soil. And as I just mentioned, when you go to the beach, that sand that you would play and build a sand castle, dig a pool, it's rough. And very important thing about it, when the waves crash up onto the shore, the water goes through. So I want you all to keep note of that property. Then we have clayey soil. We would typically find these in swampy areas, marshes. These have these are the tiny particles, and they would trap water. Then we have loamy soil, which is a mixture of the different soil types. And you would commonly find loamy soil types in our gardens, because when we have a mixture, we don't want our plants to get too much water. We don't want our plants to get too little. So the loamy soil is that mixture where we have just enough sandy and just enough clay, and the properties of both soil types would come together to give that average nature of the water capacity and holding enough water. It would drain out just enough, and it would keep back just enough. So now we have an activity. So the things you would need would be soil samples. So whatever soil samples you have, sand, clay, and loam, the general ones, a filter funnel, filter paper, a measuring cylinder, spatula or a spoon commonly used, and a beaker, and obviously water. This is how we would do our experiment and find out how the properties actually show up. So we are moving on to our activity. So today's activity, we have the first activity where we would actually look at the physical or the real soil type samples in front of us. So we have two here today. We have sandy and clay. So let's have a look at the clay. So lift them. Right. Touch it. What we could look at it, the first thing that we would notice is that the color is striking. It's dark. The particles are small. There are a few clumps, but the general particles are small and smooth. Let's have a look now at the sand. Touch it. Again, the color, and immediately you could see that the sandy type are large particles. Each and every particle, you could actually see a grain, a sand particle, and it's coarse. And it looks quite familiar as to when we go to the beach. So we already have the color. We look at the texture. we noted each of these. So when we are talking about soils in general, it's very good to employ all of our senses, as with all good scientists, to make observations. So when we looked at the sample, we looked at the color, texture, and sometimes depending on how much bacteria or organic material, broken down or decomposed material, you could actually get a scent out of it, like manure. So the soil types would have these properties that would be different from each other, and it's quite easy to observe them. So now we'd move on to how to use a measuring cylinder. So I would like to thank my assistant for this morning in the first experiment, Vritti. Thank you very much.
Thank you.
Okay. My next assistant, Aryan. Hello, Aryan. Right. So today we would like to look at the measuring cylinder. And as the name says, it's a cylinder, so we get an idea of the shape and what is used because it's for measuring. A very, very important piece of apparatus in a science lab because we use it to measure volume. So the measuring cylinder is very important as volume is a property used to measure in a lot of experiments. So what makes it be able to measure? So in a measuring cylinder, we have lines or markings, and when we pour whatever we are measuring into it, we just line it up and look at it to where the marking goes. But it's a little bit more complex than just pouring it in. In science, we have special ways in which we use our equipment to make sure we get correct measurements and our experiments work properly. So, a few things. When we are using a measuring cylinder, make sure it's dry. And one very important one is making sure the surface, wherever we are placing the measuring cylinder, make sure it's level, it's flat. When we pour liquids into them, and this is the important part here, read the bottom of the meniscus. When we look at a liquid in any vessel and we look closely, when we look at the top of it where it meets the surface, you'd see there's a little curve. That little curve at the top of the liquid in a container is called a meniscus. So when we fill a liquid up into a measuring cylinder, we would see that slight curve. And we'd use the bottom of that curve to line it up with a mark and read the volume of the liquid. So we are looking at the bottom of the meniscus to get the mark. So another very important feature is how we physically stand and place ourselves when using a measuring cylinder. We're not going to watch it cut from this side. We're not going to watch it so. We're not going to look at it from on top. We're not going to average. So if we see in the diagram, we have low reading, high reading, and a correct reading at the bottom. Even though all we're looking at the bottom of the meniscus, we have to look at it at a proper angle. And the proper angle when we are reading a volume, stoop down with me. We stoop down, don't be afraid to bend the knees, and we look at the measuring cylinder at eye level. So wherever the liquid is reaching, we stoop down and we make sure it's at our eye level to get the reading. So we have our diagram here, and as you can see, we have our markings. Come up here. So we have the person is at eye level, so the person here would be stooping, but they would just show the eye, and the bottom of the meniscus, and look at all the marks we have here. So if you notice, we have numbers in between. So we have 20, and we look at the markings. That means the divisions will tell us what each mark will be. So if this is 20, this will be 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So, very important thing to note that these measuring cylinders come in different sizes, and the units that we would use would be centimeter cube. Sometimes you would see ml, but centimeter cube would be what we would be looking at here today. So it is important that you understand and look at your measuring cylinder and the graduations and the size before you use it. Depending on your experiment, you may need a bigger one or a smaller one. Right, so we are moving on to our second activity, and here now we would be looking at the soil type and its water retention. We learned already how to use a measuring cylinder, but for the first part of this, we would need to identify all of the things that we would need to do this experiment. Your point. So first we have the filter paper, then we have the beakers, measuring cylinders, funnel, and the soil types, as we saw previously. But just as we had a certain way to look at and use the measuring cylinder, when we use a filter paper, we need to use it in a funnel, and there's a special way to use a filter paper properly into a funnel. So this is our filter paper that we are using. Usually they come in circles of different sizes. But the thing about it, if we are going to use this in this, it's not going to be neat. It could cause errors. So we need to know how to make this into a shape to fit the funnel properly. And how we go by doing this? All right. We fold it in half. Make a line, lift it up. We fold it in half, lift up flat. And now we fold it in half again on the table. Fold it up. So now we see the shape that we got. So it's getting closer to how we would be using it. So when we look at the filter paper folded, we would notice we have 1, 2, 3, 4 sheets here. What we do to make sure our sample doesn't go through the middle, we count 1, 2, 3, put that aside, and separate the last one, and we now have a cone. So our funnel is already a cone. So now the filter paper could fit perfectly in it. They are now the same shape, and we are sure our sample could rest comfortably in there without going through. Another tip when using the filter paper in the funnel is to moisten. Just wet the funnel just a little bit, so when we put the filter paper in, it would stay put. So we're going to look at measuring water. So what we are going to do now, we are going to measure out the water samples, and we would pour them in and look at how they drain. So we would begin with our measured amount of our soil sample, and in this case we have the same amount of clay soil in this funnel, in the first funnel, and the exact amount in the second funnel. So what we are going to do now, we are moving on to the next step, which is measuring the liquid. In this case, we are using the water. So the same things that we talked about when using a measuring cylinder a few slides ago, we are going to do it again. So we are using the funnel. We are going down at eye level and making sure we are looking at the top or the bottom of the meniscus. Bottom of the meniscus. Very good. So we're going to go and gradually, so Arian, could you help me? So we are going to 30, so we go down to level. We find our marking first, so we see our 30 centimeter cube mark, and we now carefully pour slow. Right, so. Stop. So we need one drop again just to make it to the 30. So just one little drop. One drop, right? All right. So we are looking at the bottom of the meniscus, and it is lining up with the 30 cm cube marking. So that's our reading. We are at eye level. The table surface is flat. So that's a good measurement. Good job, Ariane. Okay. So we are not ready for that yet. So we have to pour out another. So we're going to set this aside. So we have it there. So Ari, could you pour this into the first beaker? So we're going to set this here. And now we are going to do the same thing again, pour another 30 cm cube. So back again. So we have 30 cm cube, and we'll pour it in this one now. Right. When we are doing our practical experiments, we always keep our work area clear. So the things that we are not using immediately, we always set it aside neatly, because we always want to keep safety in our minds at all times. So we have what we have here now. Let's look at it again before we continue. Measuring cylinder with a funnel, with a filter paper, with our soil sample, sand in this one. Same thing here. The only difference in the second one is that it is clay, same amount as the sand. In the beaker, we have our 30 cm cube of water. And what we're going to do now, we are going to add the water slowly. But the next thing is we have to add it slowly because we want to make sure when we are pouring the water, it doesn't go up and flows over. We're going to make sure that all the water that we goes through, all the water we pour goes through the sample and goes through the filter paper down into the measuring cylinder. So I'll take note of the time, and Arian, you could pour gently into that one. That we are now finding out. So we need to record, write it down in a table, and it's only then we could compare what we have now to what we started with in the beginning. So I would like to thank Arian. Thank you very much, Arian, for your help. Right, so as we saw here, this is what your experiment should look like if you are to repeat it yourself. And there we see everything step by step. In this case, they used a plug of cotton wool at the base of the funnel. It is more common now to use filter paper and folding it in that method that we showed you a while ago. Our results. So anytime we are doing an experiment, our results is what we are looking for. We follow the instructions as we were given. We conduct it. We follow all. We take note. As we just mentioned, we take note of what our results were. In this case, would have been the 20 cm cube of water and the 15 cm cube of water. That's our results. So what we have here is a table. And tables are usually the best way of representing our information, especially when we are working with numbers. And if you notice, well, here we had 2 samples, but it could be as many as you are experimenting on. We have 30, this is 30, and if you notice, we just have the numbers here because we already have the cm cube up in the heading. So we don't need to repeat cm cube, we just need the numbers down there. And since we put the same amount of water, the 30 would be the same. So in the next one, the volume of water in measuring cylinder, this is where we would put our results. So in the sand, in this area, we would put our 20 cm cube again, but we don't write the cm cube because it's already up here. And the clay, we would put our 15. So we have our results. This is what we got, but we need to know what to do with it. What does it mean for our experiment? And we are looking at how it treats. So over here now, in this last section, if you notice, we have them A, B, and C to find out how much water is actually kept within the spaces in between the soil particles of each soil type we just have to work this simple mathematical equation here. Very easy. A minus B equals C. What that means, A is 30 minus whatever we got here. So in this case, for sand, it would be 20. So for this section would be 30 cm cubed minus 20, which would give us 10 cm cubed. And the same for clay. And if we had many different soil types, we do the same treatment of the results. So that wraps up the majority of what we have here. So before, we need to know and bring our thoughts together on what we learned today. So very importantly, we learned how to use a measuring cylinder, and soils have different properties, in particular color, size, texture, and can hold different amounts of water. Hope you had fun, because science is fun. Thank you very much.